Welcome to a lesson on direct variation. The goals of this video are to define direct variation and also to solve direct variation problems. But before we start, let's take a look at some real-life examples of direct variation. For example, the number of hours you work and the amount of your paycheck is an example of direct variation. For example, if you make $12 an hour, the amount of your paycheck, P, would be equal to $12 times the number of hours, or H, that you work per pay period. So for every hour you work, your paycheck increases by $12. This is an example of direct variation. Another example, the amount of weight on a spring and the distance the spring will stretch is an example of direct variation. So for example, if we say a spring stretches 3 inches for every pound attached to it, we would say the distance the spring is stretched, or D, is equal to 3 inches times the number of pounds, which we'll call P. Again, for every pound, the spring will stretch another 3 inches, an example of direct variation. And then lastly, the speed of a car, or the rate of a car, and the distance traveled in a certain amount of time. So if we let the time be fixed at 2 hours, we could say the distance traveled D would be equal to the rate, or speed, times 2 hours, which we could write as D equals 2 times R. Of course, we want to make sure that our units are the same, meaning if our distance is in miles, our rate would want to be in miles per hour. For direct variation, the following statements are the same or equivalent. If we're told that y varies directly as x, or y is directly proportional to x, or we have the equation y equals k times x for some constant k, these all mean we have direct variation, and the number k is called the constant of proportionality. So because of this equation here, in general, if two quantities vary directly, if one goes up, let's say x, then the other will go up or down proportionally based upon the value of k. And graphically, this equation should remind us of y equals mx, where the y-intercept would be 0. We have a line passing through the origin with a slope of k. Let's take a look at this graphically. This blue line here has the equation y equals 2x. So here we'd have k equal to 2. The equation of the red line is y equals negative 2x. Both are examples of direct variation, where graphically we have a line that passes through the origin. Now I do want to mention that most real-life applications occur in the first quadrant where x and y are positive, but it doesn't necessarily have to be the case every time. Let's take a look at some examples. Here we're given that y varies directly with x. So that tells us right away that the equation we're going to be dealing with is y equals kx. Next, we're told that y equals 54 when x equals 9. We want to do two things in this problem. We want to determine the direct variation equation and then determine y when x equals 3.5. To determine the direct variation equation, we need to find k. And we can do that because they told us that y equals 54 when x equals 9. So by performing substitution, we would have 54 equals k times 9. If we divide both sides by 9, we discover that in this problem, k is equal to 6, which tells us that our direct variation equation for this problem would be y equals 6x. So this is the first part of the question, and the second part is determine y when x equals 3.5. So by performing substitution again, we can find y. Y is equal to 6 times 3.5. So when x is 3.5, y is equal to 21. Let's take a look at another example. Hooke's law states that the displacement d that a spring is stretched by a hanging object varies directly as the mass m of the object. Now this is kind of a long sentence, but the most important part is d varies directly as the mass m. So the equation for this problem is going to be d equals the constant k times m the mass. Next, we're told that if the distance is 10 centimeters when the mass is 3 kilograms, what is the distance when the mass is 5 kilograms? So we can determine k because we know that d is 10 when the mass is 3. So solving for k again, we know that k is equal to 10/3. So our direct variation equation for this problem is the displacement or distance is equal to 10/3 times m. And so now we can answer the question, what is the distance or displacement when the mass is 5 kilograms? So we'd have d equals 10/3 times 5. Well, that's going to give us 50/3. So our displacement would be 16 2/3 centimeters when the mass is 5 kilograms. Let's take a look at one more example. Sometimes the equation will change slightly. What I mean by that is here we're given that y varies directly with the square of x. So it's not just y equals kx. In this problem it's y equals k times the square of x, or x squared. And from here it'll be pretty much the same. We're given that y equals 32 when x is 4. We want to determine the direct variation equation and then determine y when x is 6. So by performing substitution, y equals 32 when x equals 4. And again, remember 4 is squared. So we'd have 32 equals, this would be 16k, dividing both sides by 16. For this problem, k is equal to 2. So our variation equation is y equals 2 times x squared. And now we can answer the question, what is y when x equals 6? So we replace x with 6. Remember here we square 6 before we multiply. This would be 36 times 2, so y would be equal to 72 when x equals 6. Okay, that'll do it for this video. I hope you found this helpful.